This video is about replacing the sensor arm light bulb with an LED assembly in a Beogram 4002 or 4004. I will discuss the sensor circuitry, I will show how to upgrade it, and I will show how to install the LED assembly. For more information, please visit us at beolover.blogspot.com or go to www.beolover.com. This shows the sensor arm in action. Its purpose is to detect whether there is a record or not, and with that information the electronics of the Beogram determine whether the arm can be lowered on the platter or not. The way this works is we have a light bulb at the end of the sensor that shines light onto the platter through a lens, and then the light is being reflected back into the arm through a second lens onto a photocell, which converts that light into a voltage. And so you can imagine if there is a record under the sensor arm, then there is very little light falling on the sensor, and also the light signal will be pretty much constant, and so we will get a constant voltage from that photocell, which will be very close to zero. Now, if there is no record and we have those black ribs alternating with the highly reflective aluminum surface, then we get a significant alternating voltage coming from this sensor. And this difference in the signals, of course, can be used by the sensor circuitry of the Beogram to determine whether the arm can be lowered safely or not. It also allows it to find where the run-in groove is. So this enables the Beogram to put the needle down regardless whether you put an LP, a 10-inch or 7-inch single on the deck. It will find where the record starts and then put down the arm in the proper location. Okay, let's discuss the sensor arm circuit real quick. This here is the photocell. This here is the light bulb in the end of the sensor arm. The photocell, whenever falls light on it, emits a voltage. This voltage is fed through capacitor 12 into the base of TR3. And so whenever we have a voltage here at TR3 superimposed to its biasing voltage, then the transistor turns on, and that breaks down the voltage here at the collector to zero. And so that has the consequence that we get a amplified signal at the collector, which typically is about 6 volts, and whenever a rib comes by, it breaks down to zero. Now the capacitor here makes sure that only alternating voltages get fed through to the transistor, and if the voltage is constant, then transistor 3 does not turn on. This allows us to play reflective records. So if you have a white record or something that doesn't look black, then you can still detect it with this circuit. Okay, so this alternating 6 volt signal is fed into C16, which then goes on to the base of TR4, and whenever the voltage here goes low, then TR4 is turned on. It's a PNP transistor that is hooked up here with its emitter to 21 volts. And so when this transistor turns on, then we charge up the capacitor here. And so when the capacitor is charged, then via this 1 mega ohm resistor, we pull up the base of TR6. So whenever we have an alternating signal generated here, when the ribs go underneath, when there is no record, then TR6 is being turned on, and that means that the signal at its collector, which is normally 15 or 16 volts, is being connected to ground, and so it goes to zero here, and this is interpreted by the circuitry as a blocking signal for the arm lowering circuit. So whenever we have 0 volts here, then arm lowering doesn't work anymore, and that prevents the arm from lowering the needle onto the platter. One more thing before we roll up our sleeves and really exchange finally that light bulb with the LED assembly In order to make this detector arm circuit work reliably and according to specifications, we need to update this circuit here around TR3. TR3 is the amplifier for the photocell, and its working point should be adjusted that there is just 4 volts at the collector. This is done here with a single resistor that is connected between the collector and the base, and so the voltage here through the resistor pulls the base up, and supposedly is just turn on the transistor enough that we get here 4 volts. Now if we know exactly the HFA, the current gain of this transistor, we can dimension this resistor here properly, that we just get the 4 volts. However, across a certain batch of transistors of the same type, the one parameter of these transistors that will vary the most is that current gain. So we can assume that each Beogram has a transistor in here with a different current gain, and that means that a lot of Beograms don't have the 4 volts, and that means if the current gain is too high, which it is typically for this circuit, then the amplitude of the amplified photocell signal is too small, and that makes this detection circuit unreliable, because if you remember, this capacitor down there needs to be charged based on this voltage that makes it through to TR4. So anyway, in order to get the 4 volts here precisely, we need to change the resistor here in order to match each transistor precisely for each Beogram. And of course that is done best with a variable resistor, namely a multi-turn trimmer that we started replacing R26 with. Now the other issue of the circuit is that if the current gain is too low, then this circuit has a too small voltage gain for the photocell signal, and this may mean that the signal then is too weak to really pull down the amplitude to 0. So that usually, if you cannot get down to 0 here, and the light bulb or the LED assembly has been optimized with its position in the sensor compartment, that means then that the transistor here most likely does not have enough current gain. So we need to essentially make sure that we have a transistor here that has a current gain that is above 500. Then this here starts working very reliably, even if this is not so perfect. And we need to put here a trimmer resistor, a trimmable resistor in, with which we can then adjust the working point that we get the 4 volts. I realize this is a little bit a complicated explanation. So I made a quick and dirty simulation in iCircuit. This is TR3, this here is the biasing resistor. I already put in a trimmer. So if you look at it here, it's a 2 mega ohm trimmer that is at half position right now. So we have the 1 mega ohm here right now, and this transistor I set to 500 HFE. And so you see here, this here is a voltage gauge hooked up to the collector. We see here that we have 2.8 volt at this point. And so this is actually often what you find in a Beogram when you start working on it. The transistor is around 500, and the 1 mega ohm resistor then puts the collector to like 3 volts or a little bit below that. So if we want to adjust this to the prescribed 4 volts, so we get the big nice amplitude in our output of this amplifier, we need to play with this resistor. And so if you lower the resistance, then you see here the voltage goes down, so we need to go in the other direction. So we need to put a larger resistor here. And so you see here, if I go to 85%, we are above 4 volt on the collector. So maybe at 1.6, 1.7 mega ohm, finally we have the 4 volts here. So this is the reason why we put in this trimmer, and then for a given transistor we simply adjust it that we get the 4 volt here. Let's look real quick what happens if we have a HFE that is too low. right? Remember, a low HFE gives us poor amplification, so while this helps us with the voltage at the collector, 7 volts here now with this setting, the amplitude of the signal that comes out here would be much smaller than 6 volts, so we would have a large offset relative to ground. So when I start working on this, on replacing the light bulb in the sensor arm, the first thing is I remove the resistor and I take out the transistor and I measure the transistor to see what its HFE is. So let's get going. This shows the solder side of the main PCB as you find it when you remove the aluminum panels and the platter of the Beogram. This here is TR3 and this here is the biasing resistor R26. So the first step is to take these two components out. The next step is to flip the board up. Now we remove the two components, transistor and resistor. The next step is testing of the transistor. So the transistor is now here in this fixture and I fired up the testing process, and so what we get here is for this particular transistor is that it has an HFE of 576, and so this transistor is good enough, so we can continue using it and just put it back in onto the PCB. Back in you go. So I flipped the board back over and now it's time to solder that transistor back in. The next step is now to put the trimmer temporarily in onto the solder points of R26 from the top side here, so we can adjust it while the Beogram is powered up. So I put it in and solder it in temporarily. The next step is powering up the Beogram, so we need to plug in everything. And I usually also fixate the PCB in place with a couple screws so we don't make an accidental short circuit because it doesn't sit properly. Now we hook up the multimeter between ground and the collector. At this point it's time to plug in the Beogram and start it up. And so you see here now 3.4 volts, and now I adjust this trimmer that I get up to 4. After this we can turn the Beogram off and remove the trimmer so we can put it in from the other side. So I flip the board back up and insert the trimmer on the component side. Now board down again and we solder in the trimmer. Now the next step is to solder in a lead here that's connected to the collector of TR3 because we need to take an oscilloscope measurement while the Beogram is running with its platter inserted. So we need to be able to connect here while the platter is covering this, and so we need to put in a jumper so to connect the oscilloscope. Next step is to get the lead out of the way so it doesn't chafe on the platter. Now we can put the platters in. We don't need the belt for this, we can just manually rotate it. Okay, now we're finally ready to exchange the bulb with the LED. I put some cloth here to protect the platter underneath. And now we need to pull out the sensor compartment, bulb and sensor compartment, so you can just with fingernails grab it and then pull it out carefully. Now we can unsolder the leads of the bulb. So let's do the right side first here. And the left side. Sorry, I'm covering up here, it's a little bit difficult to get around the camera. Now we can pull the bulb out. Okay, this here shows the replacement kit. It has two components. One is an insert that goes into the bulb compartment. It helps positioning the LED board properly. So let me show you how to implement these parts. The first step is to put the insert into the compartment. And so for that you just push it in and press it down in the back. That's it. So now let's do the LED board. And here it's a good idea to bend the wires up a little bit and to the left and to the right, so it's easier to feed them through those narrow slots. This can be a little bit difficult here, and so careful pull the wires through, and then you need to put the board under that lip up front on the bulb compartment and push it down and all the way to the back, and that's it. The next step is to bend the wires up a little bit here, so that makes it easier to solder them. Here goes the other side. It is a good idea to put some flux on the solder points. And now all you need to do is touch the solder point, and that's it. There's one thing you should be aware of. There's this rivet that connects the PCB to the bulb compartment, and it's possible that these wires can make a short circuit across this rivet, and therefore it's a good idea to bend the wires away a little bit from this rivet just to make sure that there is no contact. All that's left to do is the other side. And now we can trim the wires. Before we can push the bulb compartment back into the sensor arm tube, we need to bend these wire ends here inwards, so we make sure that there is no short circuit across the tube. And so this you can just do with your finger. Before we push the compartment back into the sensor arm aluminum tube, you need to be aware that there is a slot machined into this aluminum tube to fit the lenses that here are at the bottom of the compartment. And so it is possible that the wires that are soldered to the PCB at the end can hang out of the slot, and so when you push this in with this edge here, you can damage the wires. And so it's a good idea to put a finger underneath here and feel that slot, and simply prevent that wires can hang out of the slot while you push this in. So you see this here while I do this. Here, finger, and now carefully wiggle this compartment back in. Here we see the fruits of our labor. The LED is on here, and we see that there's a nicely focused spot on the platter like it should be. That's a result of using this insert and positioning the LED properly with that. And we also see the Bang & Olufsen logo here lit up in its original color. That's a result of having implanted here a warm white LED, which has enough red photons to make this look original. And so the final step is to verify that the sensor signal is actually up to specifications. That's always a good idea after working on this sensor arm. All you need to do is spin the platter and observe that signal, and that's what I'm gonna show you now. If all went well, you will see a signal like this as the platter spins. The shape can vary a little bit. Sometimes here are some wiggles in this, sometimes it's not such a pronounced peak, sometimes this looks a little bit more rounded, sometimes it doesn't go all the way down to 0. What matters here is that the amplitude of the signal, because it's basically an AC signal that the circuit is amplifying, has a peak-to-peak amplitude that's larger than 5 volts. So here with 6.04 we are certainly in the realm of specifications, and so this here is an excellent result that came out of this LED implantation. If you don't get a curve like this, if this is too small, if this amplitude is much smaller than 5 volts, then most likely there is an issue with the LED positioning. So you might want to pull out this compartment again and see if the LED is properly seated, if this little board is properly seated. And this is the end of our video. Now you know how to replace the bulb in a sensor arm of a Beogram 400204 with an LED assembly. Like all of our parts, this part is available. Just get in touch. There is a contact form at beolover.blogspot.com, or send an email to the email address that is in the description of this video or also at the blog. Thanks for watching. I hope you enjoyed it.